Hello students, welcome back. Let us resume our discussions on natural logarithmic equations. We went through the first problem and oh boy, even the simplest problem was really long. And one of the reasons it was really long was because always you have to check for the extraneous solutions. That takes some effort. Remember that, possible extraneous solutions. Let's go to the next problem here. Okay, we have now three logarithms. How do we work out? Denominators. No denominators here. Parentheses. Nothing here. Like terms. Well, kind of. We have three logarithms and it is possible to combine those. So they're not really algebraic like terms, but they're kind of like terms. So we can combine those. Let us go ahead and do those. Okay, let's move this 3 up here. Like this. And that is equal to log of 8, isn't it? Does it make sense? 2 to the third power is 8. 2 times 2 times 2 is 8. And therefore, we get, oh, never mind. Let me just take just one more extra step. Okay, all right, just one more extra step like this. And then logarithm of combining these two, x minus 3 times x plus 4 equals log of 8. Okay, we are ready. We have log of a is equal to log of b form. So removing both of those logarithms, we get a equals to b form. Or more precisely speaking, we take exponential here to remove, exponential there to remove. We're taking exponential in both left and center right hand side. Either way, I'm going to get this. X minus 3, x plus 4 is 8. And what do we have? We have a quadratic equation to solve. Solving this, that shouldn't be too bad. X squared plus x minus 12 equals to 8. Plus check on your own. Plus x minus 20 equals to 0. X plus 5, x minus 4 equals to 0. And thus we get x equals to -5 or x equals to 4. Okay, and then what do you do now? You always check for possible extraneous solutions. When x is equal to 5, what happens there? X equals to -5. Log of -5 minus 3 plus log of -5 plus 4 is equal to 3 log of 2. You don't really have to work out. You can clearly see this is negative and that 2 is negative. So, no good. You can clearly see that. There, we have problem, and that 2 is going to be a problem. Any one of the trouble, that's going to be eliminated. When x is 4, log of 4 minus 3 plus log of 4 plus 4 equal to 3 log of 2. Is that right? Log of 1 is 0, log of 8, and then log of 2 to the third power, and therefore we have log of 8 equals log of 8. Okay, that's right. So this is okay. and this one is no good. Okay, we went through one problem like this. Let's have a brief recap. We have to combine all those logs into single logarithms, so let me remove all those coefficients first by moving all those to the powers. And then take the like terms together. You can combine the logarithms using the first two logarithm rules. And then if you have log equals to log, then you can remove all those logarithms and you get an algebraic equation. You can solve it, but in the end, make sure you come back to the original equation and check through. Log of negative, that's immediately out. Okay, how about the next problem? Pretty much the same problem, so try it on your own. Please stop the playback and try it on your own. Did everybody try by now? Assuming everybody already tried, let's go ahead. So this becomes 3 to the second power, and 3 to the second power is 9. Log of x minus 3 to x plus 1 is equal to log of 9. I don't need this much space here. So we have log of a equals log of b. We can remove those logarithms by taking the exponentials. So we get x minus 3 to x plus 1 equals to 9, and there goes a quadratic equation to solve. Okay, you can solve it, and once you solve it, check for possible extraneous solutions. Plug those back into the original equation and see. I'd like to save some time, so here we go. Okay, we have that. Solve this all the way up to this by factorization, alright? And plug in x equal to negative 3/2. Okay, more negative. That's more likely to be problematic. Plug in here, negative 3/2 minus another 3. Oh, goes to log of negative. It's not going to work out. So that's not okay. And this is okay. Sorry about that. I made a typo and reversed those. Log of negative is not okay. It's not work out. With x equals to 4, then that's going to work out. 4 minus 3, that's log of 1, and this one is going to be log of 1, that's 0. And then right hand side, that is log of 9. 3 squared is 9, so this is going to be okay. If you're unsure, you can always check your calculator. How about this kind of problem? We have two logarithms, and then we have division here. Be careful. This is wrong. This is wrong. You see, we have division, and we have division there as well. Same multiplication, same division, the same addition. No, that's not the way log rule works. Logarithm changes multiplication to addition, and division to subtraction, and vice versa. So always you have to change the algebraic operations. So this kind of thing will not work. Works like this. Log of 2x plus 3 equals to 2 times log of 3x plus 2. Flipping the denominator to the other side. And then we can remove the coefficient. like this. And finally, removing the logarithms, 2x plus 3 equals to 3x plus 2 squared, and this is a quadratic equation to solve. Break up the right-hand side, take all those like terms together and put those into the standard form, equals to 0, and then factor those, you can find x values. Once you find those x values, make sure you plug all those back into the original equation so that you have correct solutions and illegitimate solutions. I'd like to save some time, so let me show you the answer key here. Okay. Move the denominator away like this, alright, and take the logarithms of both. We get this equation, and then from this point on, just use routine algebraic work. Turns out -1/9 or -1. Okay. Plug in -1/9, what happens? -1/9 plus -2/9 plus 3. -3/9, so -1/3 plus 2, they're both positive. And then if you calculate those out, well, they will work out okay. If you're unsure, you can always punch in the calculator and then see if you have something really close to 2. Now, if you plug in x equals to -1, that's more negative, so it's more likely to fail. Indeed, the denominator fails. -3 plus 2, that's log of -1. That's undefined. So we have only one solution, like that. Oops. How about the last problem here? Kind of similar to previous problems, so go ahead and work out. Remove the denominator, flip it to the other side by multiplying it, and then go from there, simplify, remove the logarithm, and so on and so forth. Did everybody try? Stop the playback and try. Assuming everybody already did, let me go ahead. Flip the denominator to the other side, and then you're going to see this one and that one would cancel each other out. We have one log equals another log. Not ready yet. This 2 must go, otherwise you cannot take the exponential of both. You cannot just remove log here. That's incorrect. But if I move this 2 on top like this to power, now I'm ready. I can remove log, and then you're going to get x minus 2 total quantity squared is equal to 2x plus 1, and solve the resulting quadratic equation. Basically what we do here is taking that exponential and then exponential. Therefore, we are getting this logarithm away. Solve it, we get -1 and +7 and plug those back in. X equals to -1 is more likely to be a problem because that's more negative. Indeed, plug in -1 minus 2, that's going to fail in the numerator. It'll turn out x equals to 7 is okay. Beware, sometimes both of them are illegitimate and then you end up with no solution. It can happen. I rarely write those kind of problems in the exam because it may make a lot of students panic unnecessarily, but in homeworks you may encounter some